Hello ladies and gents, and welcome to Web Wizzards, identifying, exploiting, and automating server-side template injection and type juggling attacks. So, who am I? Well, I go by Eternal Paradox, and I have liked the digital world since I was a child. First as a game developer, then as a web developer, and now as a cybersecurity practitioner, with the hopes of becoming a true professional of the craft someday. Some of my coolest accomplishments were getting my OSCP at 18, securing my OSC3 at 21, and getting a penetration tester role. Currently been a year and going strong. My passions are mainly three: hacking, working out, and being a weeb. Anyways, enough about me. Let's get to the good stuff, since there is a lot to cover today. So, what things are we going to cover? First, we will start with the foundations of what are templates. Next, how do classes work, and what is server-side template injection? Then after that, how to identify, exploit, and automate such vulnerabilities. Right after, we will switch to type juggling. For that, we'll need to understand concepts such as loose versus strict comparisons and magic hashes, which will allow us to be able to reach to the identifying/exploiting and automating phase of type juggling. Now, important disclaimer. Despite these are advanced techniques and they might seem scary initially for someone who hasn't spent many years in web hacking, I can assure you that I will do my best to make sure that every one of you watching and listening today will be able to understand, perform, and automate such attacks after watching my talk. So what are templates? Templates are like the blueprints for your web's application's user interface. They are a powerful tool that let us separate the design and layout of a web page from its backend processes. Think of them as a way to dynamically display content on the web pages without having to manually code every single HTML element. Within templates, you can define the structure once, like a master page layout, and then insert different content into the structure as needed. This makes creating and maintaining web pages far more efficient and less error-prone. Let's say you run a blog. Without templates, you'd be writing the same HTML for every article every time. But with a template, you set up the article structure once: title, author, date, content, and then just plug in the different text for each post. Different programming languages use different templating engines. For example, if you're working with Python, you might use Jinja, which uses double curly braces to insert variables or expressions that get replaced with actual values when the template is rendered. In Ruby, you'd use ERB, which has a similar concept but with different syntax, using end Ruby within tags. JavaScript has several options like AGS and handlebars, each with its own syntax but the same core concept. Twig for PHP, Family for Java, and ASP.NET Razor for C# are all templating engines that allow developers to build dynamic content on web pages efficiently. This means when you visit a web page and see your name on it, there's a template working behind the scenes. The server takes your name from its database and plugs it into the template, where the placeholders for the username appears, generating your own personalized page. So, to sum it up, templates make a developer's lives easier. Now, as a hacker, your sixth sense should start raising alarms when you hear things like, oh, super efficient, or things like allows you to dynamically show content. Still don't see it? Allow me to help you. Now, if a website uses a template engine that hosts dynamic content, but the user has no type of interaction, then all good. But what would happen if the website allows the user to create its own dynamic content, i.e. templates? Basically, server-side template injection happens. So what is server-side template injection? To put it simply, SSTI occurs when an attacker uses native template syntax to inject a malicious payload into a template, which the server will then execute. Notice those two images on the right? If those are SSTI. Now let's first focus on the topmost one. Basically, I'm using common Jinja 2 syntax to compute a simple calculation of 3 times 3, and then I look at what the server returns, which is 9. Hence, the server is executing my template, which I have control of. Now, obviously, displaying mathematical answers is cool and all, but we hackers, we always want more. Hence, below that image is me showing an example of achieving remote command execution, and yes, I will go over on how to do all of this, don't worry. But first, let us start in seeing how we could identify such vulnerabilities. Now let's look at identifying SSTI in action. On my left, you can see a block of Python code written for a Flask application. Key points to note: user input is being directly interpolated into a template. This is a classic example of where things can go wrong. The code uses an f-string to insert the user's name into a greeting. Seems harmless, right? Well, if you look closely, you would see that purple squares are highlighted. In them, an attacker could write any string, which then will be executed server-wise. Now, since the code in action uses render template string, if the attacker decides to actually put a template string such as 7x7 and sees hello 49 comes back at him, then he has confirmed that there is indeed SSTI. So yes, basically when reading source code, make sure that any type of rendering function you see that any server uses, check if the input of such function being passed is actually controllable by you. With that said, where would we find such vulnerabilities? Well, they're not just in niche or poorly maintained applications. We're talking about widespread use across various platforms. For example, a couple listed on the right: web apps for Jinja 2, Flask, or Django, Ruby on Rails, Node.js, EJS on Bus Bug, Turgos Money on PHP, Family FreeMaker on Java, and ASP.NET on Razor, and then Node.js and Express.js. And it's not just web apps. SSTI can be found in content management systems like WordPress or Drupal, and e-commerce platforms, where templates are commonly used for product descriptions and emails. The bottom line is this: whether there's a template engine and a user input, there's potential for SSTI. Or as I like to call it, if 7 times 7 renders to 49, have fun. Now, sadly, before we can go into exploitation, we must understand the components of classes. Put on your seatbelts because this is pretty hard. So what are classes? It is important to note that in Python, everything is an object, and every object has a class. Classes can be thought of as blueprints for creating objects that share a certain set of attributes and behaviors. Now suppose the following example from this slide. We have a base class sport, which we can consider as a generic category. Sport has attributes like equipment and team size that apply to all sports. Now, if we move to a more specific type of sport, like a team sport, it inherits all attributes and methods from sport. Then, if we want to, we can get even more specific with, for example, a soccer class that inherits from team sport. Then a layer below, we have equipment, which is values equated to soccer ball. Now, to make this simpler to understand, let's think of programming with classes like growing a tree, starting with the seed and expanding into a full tree with branches and leaves. The seed of our tree in Python is the base class sport. It's a foundation that contains all the basic elements of sports in general, such as equipment. This could be anything used in sports, like balls, nets, or rackets, hence the generic sport equipment value. As our tree grows from the seed, we get to the first branch, which is team sport. This is a more specific type of sport, but still quite broad. It inherits everything from the sport class, which means it also has equipment, but it adds its own characteristic, team size, which is relevant to sports played by teams like football or basketball. Then, branching out further, we get to a smaller branch, the soccer class. It's even more specific, inheriting all properties of sport and team sport, but it's specialized with its own equipment value set to soccer ball. Just like a branch that grows leaves specific to its type, soccer has properties specific to the sport. But how does Python solve all this? How does Python know which method or attribute to use when you have several layers of inheritance going on? Well, that's where the method resolution order, or MRO, comes to play. It's a rule that Python follows to determine the order in which base classes are searched when executing a method call. You can actually see this order by accessing the MRO attribute of a class. For instance, when you check soccer.mro, you see it lists the class hierarchy from soccer back to the built-in object class. Python uses this order to resolve which method or attribute to call. So if you access soccer.equipment, Python checks soccer first, then team sport, and then sport until it finds equipment. Now what about the subclasses method? Well, this shows us a list of immediate subclasses for the class. In our example, team sport subclasses would list soccer, since soccer is a direct descendant of team sport. Understanding classes and inheritance is fundamental to achieving server-side template injection. Now let's move actually into the actual exploitation phase. Now suppose our attacker goal is to read sensitive files like int password. How would we go about it using what we learned before? Well, there is a very handy class that Python objects use called file.io, which has methods for reading and writing files. See where I'm going with this? Let's break down the steps to do this. Step 1. We can access the method resolution order MRO of the 1337 integer object with 137.class.mro. This reveals that it's an int object, and like everything in Python, eventually events, even ints, inherit from the base object class. Step 2. We do 137 class MRO on subset 1 of index 1, because we know that's where the object class in, and then we list subclasses. And that will basically give us the other stuff. So in this case, we want to look for IO base, which is where we go to step 3, which is we now use subclasses on index 92, which is the index of IO base, which is part of Python's IO system. Then on step 4, we list yet again subclasses to go even deeper of the subclasses for IO base, which can basically give us read and write files. Now in this case, it's raw IO base. Now raw IO base is actually in index 0, hence we put subclasses of 0. Then same concept, we're on step 6, we do the subclasses again. Now we want file.io, which is the one that allows us to read and write files. So put it on index 0. So now we basically have 137.class.mro1, remember, mro1 means object, then subclasses 92, remember, that means IO base, then subclasses 0, that means raw IO base, and then subclasses 0, that means file.io. Now that we reach our goal, we just need to read the password. So how do we do that? Well, What's happening here? We have this 137 class MRO1, subclass 92, subclass 0, subclass 0, etc. password r.read. Let me explain step by step. So first we access the file IO class by navigating Python's internal classes via the MRO and subclasses method. So that brings us to almost etc password. Then we create a new instance of the file IO class with etc password as the file to open in read mode. And finally, we call the read method that file IO provides on this instance to read the contents of the file. So with that, we successfully SSTI'd our way into getting its password. This is cool and all, but can we go one step even further? Now suppose our goal is to get remote command execution. Then this payload we would use would be request.application, globals, built-ins, import OS, popen, who am I, the ID for example, whatever you want to put, .read. So how does it work? Pretty long, right? Well, let's go step by step. Request application is the accesses the Flask application object. In this case, the Python object. Globals gives us access to global variables within the Flask application context, which gives us built-ins. And built-ins is a reference to the built-in objects provided by Python, which includes the import function. Now, as a hacker, you love the import function because you can import something called OS, which is the next step. We do import OS, which basically dynamically imports the OS module and then will allow us to use things like popen or process open. Process open allows us to run any single command in the system through a subshell, basically. So then we can just do popen who am I, and then once that's done, we just use the .read method since we want our output to be reflected. Basically, what this means is that when the server processes this template, it will essentially run the who am I and ID command and return the output as you can see on the screen. Now, I know this is hard, which is why I will do a quick demo showcasing each step and going through it together. Hopefully the demo gods are with me today. So we'll start with listing the MRO. Remember, we're looking for IO base, so the way we would do it is we would cat for object. Then after that, since object is in index 1, we'll start by listing MRO 1 and then subclasses of it. Once that's done, we'll see all this. Remember, we're looking for IO base. IO base is here, and you would have to count every single index, but basically, it's in index 92. We can verify this by just doing subclasses of index 92 and seeing that we indeed get IO base. Next, we'll list the subclasses. Remember, now we're looking for row IO base. So there we go. We can see row IO base in index 0. So to verify, we can do subclasses 0, row IO base. We can then again list subclasses on it to reach file.io, which we'll see in a minute. There we go. File IO is in index 0, which we can verify by just doing subclasses of 0. As you can see, it's just same repetitive process, just recursive searching of file.io. There you go, file.io. And then finally, we can use file.io read method to read our etc password. And then, as I promised, remote command execution. So here it is. I am using a different command just to show you that there's different ways, but basically, same thing, request application globals, built-in, import OS, then popen, and then whatever command you want here. So for example, we can say, hey, list everything on root. And there you have it. We achieved RCE. Now, let's get back to theory. So I hope you enjoyed this. Let's go back to theory. So how do we automate SSTI? Well, now that we know how to exploit this, on the next step, automating server-side template injection, there's not a lot of difficulty in it. We just gotta use a super handy Burpsuite extension called copy as Python request. I made a video to show you how to do it. So we intercept the request, then we just copy, send it to extensions, copy as Python request, copy the code, paste it. Very quickly, what's happening here is basically we're getting all the necessary tools to automate our GET request. So Burp is providing us a Burp URL, the headers, the data, which includes name, and then our entire SSTI get password injection. So then we can just add a response variable and then print response.text, which will reflect the output of response. And now when we run it, there you go. We get its password. All right, so up next, type juggling. What is type juggling? Essentially, type juggling is the event where during the comparison of variables of different types, PHP will convert them to a common type. Let's explore this further. Take a look at my script I wrote. We have two variables, $val1, which is set to the string 10, and $val2, which is an integer with the value 10. When we use the loose comparison operator, double equal sign, PHP performs type juggling. It converts the string 10 to an integer 10, and then compares the values. Since the values are the same after type juggling, they become equal. Hence, we get the 10 and 10 are considered equal message. However, when we use the strict comparison operator, or the triple equal sign, PHP requires both the value and the type to be the same for the two variables to be considered equal. In this case, since val1 is a string and val2 is an integer, even though their values are not the same when typecasted, their types are different. Thus, the output is using triple sign is not equal. Well, basically, we get 10 and 10 are now considered equal, for obvious reasons. This difference in behavior is based on how PHP interprets double equal sign, again, loose operator, or compared to triple equal sign, again, strict comparison. The double equals checks for value equality after type juggling, and the triple equals checks for not only value equality but also type equality. Hence why we get 10 and 10 are not considered equal on 3, and 10 and 10 are considered equal on 2. Now, this not only happens comparing a string and an integer. As you can see here, in more detail, loose comparisons allow many more comparisons to return true, to which as an attacker we love, since getting things to become true equals being able to bypass things, which we'll look at later. So how do we identify type juggling? Let's take a look at the script to understand where it happens and how it can be identified. In the script, we have a simulated user data array where the password for admin is set to 0. This is a numeric value, which will be loosely compared to an MD5 hash of the password the user submits. This is where type juggling can occur. When a user submits their username and password, the password is hashed using MD5 and stored in password hash. The if is said user username and password hash equals user username statement uses the loose comparison operator. This is vulnerable to type juggling because if the MD5 hash begins with 0e, which is formerly known as a magic hash, PHP will interpret it as an exponent in scientific notation, which is numerically equivalent to 0. Since the password in our user array is also 0, PHP will consider them equal due to type juggling, hence it will bypass the login. Okay, but before we go deep into magic hashes and all the good stuff, we really need to understand the trick. So let's try to understand where we can find this type of vulns. Well, any place that relies on PHP, for example. As you can see on my right, content management systems, e-commerce platforms, web form templating boards, customer relationship management systems, blogging presentations, web-based database administration tools, API endpoints, and authenticated systems. They rely either on cookies or session data. Now, I like to say that essentially any double equal sign you see in the in any PHP application is usually a dead giveaway that type juggling attacks can occur. Now, before we exploit, we must understand how magic hashes work. So what is this magic hash that I keep mentioning? To put it simply, a magic hash is a hash value that usually is either MD5 or SHA-1 that due to PHP's type juggling equates to 0 when compared with a number using loose comparison. Let's delve in more into how this works. As you can see on my script on the left, what happens when a so-called magic hash is loosely compared to the number 0 in PHP. The variable magic hash contains a string 0e462 yada yada. When PHP encounters a string in a loose comparison with 0, it sees 0e followed by numbers. This 0e is interpreted as 0 times 10 to the power of yada yada, which mathematically equals 0. Now look on top of the right screen, we see 0e to the 5 is the same as 0 times 10 to the power of 5, which anything 0 times is 0. Same concept, we now have a magic hash. 0e is the same as 0 times 10 to the power of whatever the magic hash has, which equals 0. So in the script, when the loose comparison if magic hash equals 0 is performed, PHP interprets magic hash as 0 because it starts with 0e, making the statement true, which is why the echo statement matched with double equal sign is executed. Now, as you can see on my right, there are people out there that work on making magic hash tables. By that I mean a list of strings with their corresponding magic hash. This allows us to cut a ton of time that would take brute forcing them otherwise. Now look at the table and focus on the highlighted string I squared. This will be used on our exploit later, that being 240610708. Let us now go into the actual exploit and see how original code would be bypassed. Knowing how type juggling and magic hashes work, we can now get a better sense of how an attacker could exploit this. First, we can submit the username admin along the password 240610708, which is the previous table string we saw in the magic hash table. That, when hashed as an MD5, produces a magic hash. Hence, when the password is passed through the MD5 hashing function, it produces the 0e462 yada yada magic hash. Because of type juggling, when the hash is compared to 0 with the loose operator, as we saw, PHP interprets both sides as numerical values. Hence, the hash is interpreted as 0, since anything to the power of 0e is 0, and 0 equals 0, we know that to be true. Hence, we bypass the login, we grant access, and we get PHP type juggling. Now that we understand it, let's demo it. So, if I go here, and I do, admin, and I try it, we get login failed. But if I do admin and then the actual string, which is 2406100708, remember, makes a magic hash gets interpreted as 0, 0 equals 0 is true, hence, badam, we bypassed the login. Cool. Hope you guys enjoyed that. Now, one last step. After demo, we get how to automate again. So, you probably guys guessed it, but hey, we use copies Python request again. So let's see how we do it. Yep. Oh, also for anybody that just came here and is learning how to do this, Burp Suite, this is called Burp Suite, the thing on the right. Basically, this is man in the middle, any conversation the web browser has. So we're basically intercepting the request, which is passing admin and password as you can see below. And then we're going to use extensions to copy a Python request to copy the code. That's going to allow it to produce a nice Pythonly formatted code. Then we're just going to do again what we did last time, response equals, but this time since it's a login, we're going to use an if statement to check if the contents are properly. Now, if you recall, when we logged in successful, we had, hey, logged in successful, you're now a type juggling hacker. So you can just literally put, hey, if that statement in response to text, then print congrats, meaning we successfully PHP type juggled, else, unlucky, we didn't do it properly. So let's test it out. So when we run it, bam, we now successfully type juggled. All right, now to finish off, here are some of the useful resources I found while researching. Hope you guys find it helpful. And with that said, any questions, please feel free to chat in the messaging. I'll stay here for a while. Oh, okay, I can start seeing questions pop up. Could you use type juggling to search for other user accounts? Probably not. So type juggling is more to bypass login accounts. Maybe what you can do is use that and then get a new, find a vulnerability, like an IDOR, an indirect direct object reference, to then list other user accounts, for example. Is only PHP vulnerable to the juggling, or also, for example, JavaScript? If I am not wrong, I believe this is only something that PHP does. Hence, I would say that PHP type juggling is only vulnerable in PHP infra. Can this method be used other than in a sign-in page? Probably if it uses any type of authorization, right? Although in mostly my pentests, I always find it in login screens. However, perhaps maybe like a message authorization? Well, will this recording be? Probably in the YouTube channel of Dropout Freaks, but that's not for me to decide. That's for the admins. For people working in InfoSec, how would you remediate this vulnerability? It's a good question. So for PHP type juggling, it's literally just you pass from a loose comparison, which is double equal sign, to a strict comparison, which is a triple equal sign. So that's literally how you would mitigate it. And then for the second, which is server-side template injection, you would basically not allow the user to have any type of input control over any template. So instead, you would have to do some type of input filtering or sanitization, or just, hey, display the template by never letting the user actually run it. I'm currently going through my OSCP and plan to take it next month. What other courses would you recommend? Well, if you remember, I'm an OSC3 and highly recommend, for example, OSWE. These two vulnerabilities are part of the OSWE, and it really helped me understand many different things. What kind of applications use PHP for logins? Well, as we talked, many different things, right? E-commerce, CMS, perhaps things that use databases, since PHP goes hand to hand with database management, for example. Is there any way I can check out that SSTI template injection or any resource you have for it? Yes, I will be providing after this some slides, like a shorthanded resource with their payloads, where to find the vulnerabilities, the resources I used, and any other tips I recommend, for example, to mitigate them. How do you know if the web page is accessible to type juggling? Again, as I said, you're looking for the double equal sign, the loose comparator. So if you see that there's some type of like login equal if condition stating where there's two equal signs, and you see a string is being compared to like a hash, then probably the giveaway that it's PHP type juggling. All right, that would be all then. We'll have no more questions. Then thank you so much for everything. For the people in Discord here, thank you so much for listening. And then for the people that will see this in a recording later and not in Discord, this is my Discord. Feel free to message me and ask any questions you have. And with that, ladies and gents, I'm out.